guys. So it's been a while, but today we are going to talk about LEM versus bivalence. So what is LEM? Well, LEM is a syntactic axiom. It is a law of logic, as many of you guys put it, colloquially speaking. And very simply, it is this. It says P, disjunction, negation P. That's all it is, right? It just tells you what you can write down, right? If we just go into what it means very formally speaking, LEM constrains the proof system by forcing every proposition to appear with its negation as an alternative. The example here is the dog is white, which is the P. The dog is not white, which is its negation. So it's just telling you that as a axiom, that is, you are allowed to write it down as something that is further not derivable, but you're able to derive other formulas from it, syntactic ones. So what is bivalence? Bivalence is the claim that every proposition has exactly one of two truth values, which is true or false. So a lot of people associate or call bivalence the classical form of semantics of LEM, which is just to say that bivalence says the proposition is going to be either true or false. Notice, LEM does not say anything about true or false, but bivalence does. All right, so here it says bivalence does not just tell you what you can write down like LEM. Rather, it forces only two values, one on each side of the disjunction, then forces only one of them to be chosen as true. So under bivalence, there are only two values to choose from, and you must choose one of them. Notice, LEM doesn't tell you any of that, right? The law of excluded middle simply tells you what you are allowed to write down as an axiom to further derive formulas for the proof system. But bivalence forces you to enter into each side of the disjunction those two values, with true and false. So what's the motivation for this? Why would you put them together? Well, the most practical motivation is that if you prove P is false, you can automatically infer that its negation is true. This is with LEM plus bivalence. So if we say there is a dog on a table is false, that means there is no dog on the table is true, right? If we can prove one end of the disjunction is not the case, then that means the other end of the disjunction is true. That's in classical semantics. Remember that by pairing them together, classical semantics and LEM, we're going to say that it is true that there is a dog on the table, and then the other end of the disjunction is going to be it is false that there is a dog on the table. So what would happen if we use LEM without bivalence? We write LEM there, P, disjunction, negation P, but then we add on a non-classical semantics. So we allow for indeterminate values. We add true, false, but then we add a third value. So we have a three-value system here. Now, what is this saying here? Well, let's look at a truth table, and I'm sorry, this is kind of a messy truth table, but we have P and its negation. So here we are going to use the three-valued system, and we're going to input true and false, which, if you know disjunction, at least one of the sides has to be true. So the first one's going to come out true. You can swap the second time false and true. And because one end of the disjunction is going to be true, then the
disjunction is satisfied, so it's true. But in the three-valued system, when we have an indeterminate value, because the negation of indeterminate is just indeterminate, you have indeterminate on both ends of the disjunction, and because it fails to be the case that either side is true or false, the disjunction is indeterminate. So you are allowed to write down LEM, which is the top part, but the semantics, which is the bottom part, the values that you're inputting into LEM, is going to affect the outcome of that truth table.
So keeping LEM can be used, but it is not guaranteed the disjunction will come out with a true or false value.